Welcome to Geometry. This is Mr. O'Shea. We're going to do 6.4 today. And 6.4 is talking all about special parallelograms. When we're talking about special parallelograms, really we're looking to use the properties of the diagonals of both rhombus and rectangles. And also we're going to determine whether or not a parallelogram is a rhombus or a rectangle. So we've got a few theorems here. The first one's theorem 6-9, and it deals with rhombuses. Each diagonal of a rhombus, and remember diagonals are just things that connect two opposite vertices. These diagonals bisect two angles of the rhombus. So each diagonal bisects the angle that it really comes from. And we'll kind of mark up this diagram here to illustrate that. So the diagonal that goes from the top to the bottom, let's make that a little straighter. It bisects both those angles. And now we know that that top one's going to be congruent to the bottom one because in a parallelogram, opposite angles are congruent. So really all four of those angles are going to be congruent. And we also have another diagonal from the left to the right, and those angles we'll do it with 4. Those two are congruent because they get bisected, and the other the other two angles that we marked with 4 are also congruent. So that's the first theorem. The second theorem, 6-10, and again, not really worried about the numbers here, just more so the ideas, is that the diagonals of a rhombus are perpendicular to each other. So when they cross, they do so at 90-degree angles. And that's true for all rhombus. So whenever we have two diagonals that cross on a rhombus, we know that those angles on the inside are always going to be 90-degree angles. So we got a little example here. MNPQ is a rhombus with angle N 120 degrees, so we'll mark that. And we need to find the measures of the other numbered angles. So that one's 120. Now, because it's a rhombus, we know the diagonals bisect the angles. So angle 1 and 2 are congruent. And it's a parallelogram and opposite angles are congruent. So angles 3 and 4 are also congruent to 1 and 2. Now, we've got a triangle there on the top, and that triangle is going to be triangle MNP. So we know angle 1 plus angle 3 plus 120 degrees, or angle N, I should say, equals 180 degrees, just based on the fact that that makes a triangle. Now, angle 1 and angle 3 are congruent. Based on the fact that angle N is 120 degrees, we'll subtract 120 from both sides, which means angle 1 plus angle 3 is 60 degrees. Now, what we were saying is that angle 1 and 3, because they're congruent, we could just say angle 1 plus angle 1, right? 1 and 3 are the same thing, so angle 1 plus angle 1 is 60 degrees. Be like us saying x for angle 1. It's just the same thing as angle 3. So it'd be 2 times the measurement of angle 1 is 60, which means angle 1 is 30 degrees. Now, based off that information, 1, 2, those are both going to be 30 degrees because they're congruent. And angle 3 and 4 are opposite angles, which are also congruent based on the fact that it's a parallelogram. So all of those angles are going to be 30 degrees. Our next theorem has to deal with rectangles and the diagonals that are connected there. The diagonals of a rectangle those are going to be congruent to each other. So if we connect those down, those two that I just crossed are going to be equal to each other. We can say AC is congruent to DB, but that would help if we actually wrote out A, B, C, and D. So we can say AC, the length of AC is congruent to the length of DB. All right, find the length of the diagonals of the rectangle GFED if FD is 2y plus 4, so we'll label that, and GE is 6y minus 5. All right, it's a rectangle, so we know the diagonals are congruent, so we can say that 2y plus 4 equals 6y minus 5. We'll bring the 5 over to that side, ends up giving us 9, and we'll bring the 2y to the other side, give us 4y. Divide each side by 4, and we find out that y equals 2.25. Now we're not done with the problem because it actually asked us to find the lengths of the diagonals. So we're going to have to take that 2.25 and go ahead and plug it in for the diagonals there. It doesn't matter which one we do because theoretically they're congruent, so we can plug it into either one. Scroll down a little and go ahead and take care of that. 2y plus 4 equals something. Let's go ahead and plug in 2.25 for that. 2 times 2.25 is going to give us 4.5 plus 4 equals a grand total of 8.5. Which means the length of FD is 8.5. And it's a rectangle, so GE is also 8.5. All right, and our second objective that we want to kind of cover is if you're given a parallelogram, we want to be able to tell whether or not it's a rhombus or a rectangle. Now we've got a couple of theorems that are going to help us do that. The first one is theorem 6-12, and basically what that theorem states is that, oh, that red is a bad color on there, let's change that. If one diagonal of a parallelogram, so if one diagonal bisects, so if one diagonal of a parallelogram bisects two angles, it has to bisect both angles. So if one diagonal bisects two angles of a parallelogram, then that parallelogram is going to be a rhombus. So again, that's that idea of diagonals bisect the angles. Anytime you guys have that, it's going to be a rhombus. And we'll try to draw a quick picture of that. We have a diagonal. If you're given something that looks like this, and it bisects both angles. Now here's the key too, guys. It's got to bisect the angle from the left and the angle from the right. So if it bisects both of them, it's always going to be a rhombus. All right, 613 kind of follows that same idea. It's talking about the diagonals of a parallelogram again. And this time around, if the diagonals of the parallelogram, if they're perpendicular, so if the diagonals of a parallelogram are perpendicular, so in other words, if those diagonals make right angles, then we know that shape is going to be a rhombus. So if the diagonals are perpendicular to each other, then it's a rhombus. Quick sketch of that. connect our diagrams or our diagonals here, and when they connect, they make 90-degree angles. I know my picture doesn't really look like it, but these are more of those ones that will go off of the information that it gives us. All right, in 614, no longer talking about rhombus. This time around, if you have diagonals that are the same length, in other words, if the diagonals of the parallelogram are congruent to each other, so if diagonals of a parallelogram are congruent, then what that means is that the shape is actually a rectangle. Now, the diagonals, whether they're congruent or bisecting and whatnot, those are really the major difference between rhombus and rectangles. So now we're going to an example here, example 3. And what I want you guys to do, it's just a couple of statements. The first one is that a quadrilateral has a congruent diagonals and one angle of 60 degrees. And then the second statement is a quadrilateral has perpendicular diagonals and 4 right angles. And we want to figure out what kind of a parallelogram these are. So the first one, quadrilateral has congruent diagonals and one angle of 60 degrees. Now, congruent diagonals should be hinting at the fact that it's a rectangle, right? But unfortunately, rectangles have 90 degrees, not 60 degrees. So this one is actually not possible. It's not going to be anything. Let's take a look at the second one. It's got perpendicular diagonals and 4 right angles. So perpendicular diagonals, we had said that that's that clear indication of a rhombus. Let's go ahead and draw this out here. I'm kind of cheating because I already know what the shape has to look like in order for this to work. But if you see, I got the 4 right angles, and I'm going to try to draw perpendicular diagonals here. Okay, there we go. And the perpendicular diagonals hint at the rhombus. Now the 4 right angles, the big angles, hint at a rectangle. Now, if you guys think back to that flow chart we did, we said that anytime you have something that is both a rhombus, based on the diagonals, and a rectangle, based on the 4 right angles, we can actually go further than that. We don't stop there. We're going to go ahead and say that this one is a square. That last one, example B, is actually going to be a square. All right, I will see you guys in class tomorrow.